Many material tests investigate the behavior of a material under a dedicated load. Therefore, strain shall be measured. Strain is defined as the change in length of an object in a specified direction. An extensometer measures the change in length delta L. To determine length change, a two-point distance with a defined length is used. Lengths are often specified in norms and standards. You can comply with norms by using a given length and direction. You can also compare the change in length of a specimen in multiple measurements. An extensometer requires a defined length. In V8SR1, you can measure a distance by defining 2 points. Then, the length is computed automatically. That means you cannot set the length between the points accurately. To initially set the length is essential for creating an extensometer complying with norms. In Aramis Professional and GOM Correlate 2016, you can choose length and direction. Therefore, you can now create an extensometer in GOM Software 2016. The extensometer function offers a non-contact measurement of the change in length of an object. No mechanical contacts can influence the measuring results. In addition, you no longer use expensive mechanical extensometers that might get damaged during testing. The extensometer function allows the tracking of the length change during a live measurement and in the post-processing within the inspection workspace. The new function can be used in 2D and 3D projects. To create an extensometer in the GOM Software 2016, you can start with a facet point. To create a facet point, click a point on the stochastic pattern of the left camera image. The software places a facet around the clicked point. In a stereo camera setup, the system identifies the facet of the left camera image in the stochastic pattern of the right camera image. The software can trace the facets stage after stage. In GOM Software 2016, you are able to create a facet point within the facet point dialog. To generate an extensometer, you can choose an existing facet point or create a new facet point. To create a facet point, click Ctrl and left mouse button on the specimen. Following, you set the direction of the extensometer. The software identifies the end facet point on the specimen. The direction is displayed corresponding to the coordinate system in the 3D view. The given length is equivalent to the distance between the start and end facet point. With the expert parameters in the dialog, you can define how the software computes the extensometer. Facet matching against the definition stage is based on the stage in which the facet point was created. This allows to easily recover facets which are not identified in a stage. For example, if the facet is temporarily hidden behind other objects. Facet matching against the previous stage minimizes the risk of losing points in case of strong deformations. Based on the extensometer, you can check the length change. You can view the change in length in each stage. To determine the change in another direction, you can create another extensometer. You can choose any direction, not just X, Y, and Z. You can check the change in length in 2 or even more different directions within one project. In the diagram, you can see the percentage change in length in each stage.